Let us see some examples. So the first example is if Sn is non-decreasing sequence, non-decreasing and bounded above, and L is limit of sequence Sn, then prove that Sn is less equal L for all positive integer n. So the solution is, since this sequence Sn is non-decreasing and bounded above, so therefore limit of sequence Sn is least upper bound of this sequence, that is, and limit of sequence Sn is L, so L must be least upper bound of these terms of the sequence. Since L is least upper bound, that is, L is least upper bound of the set which are having term of the sequence Sn. So what we must have? Every term of the sequence must be less equal L for any positive integer n. Right? The second example, if Sn and Tn, sequence Sn and sequence Tn are non-decreasing bounded sequences, and if Sn is less equal Tn, every nth term of sequence Sn is less equal nth term of Tn for positive integer n, then the limit of sequence Sn as n tends to infinity will also less equal limit of sequence Sn Tn. N tends to infinity. So the solution, since sequence Tn is non-decreasing, and bounded, so by the theorem, so it is bounded above by the theorem, bounded above. Therefore, and again by the theorem, a sequence non-decreasing and bounded above sequence is convergent. Therefore, sequence Tn is convergent. Therefore, limit of sequence Tn is least upper bound of the set which include the terms of the sequence, which is equal to, let us say it as L. It is only to say. Therefore, Tn is less equal L. Every term of the sequence Tn is less equal L. Now, since Sn is less equal Tn for all positive integer n, and we have Sn is less equal L because Tn is less equal L for all positive integer n. Therefore, it means what? Sequence Sn is non-decreasing. It means the sequence Sn is, it implies that sequence Sn is bounded above as sequence Sn is, therefore sequence Sn is non-decreasing, because it is given that sequence Sn is non-decreasing, and as it is bounded above, so by the theorem non-decreasing and bounded sequence is convergent, hence sequence Sn is convergent, right? Therefore limit of sequence Sn as n tends to infinity is least upper bound of the set which have the terms of the sequence Sn is, let us say it as sum m. So since Sn is less equal L for all positive integer n, so it implies that m is less equal L, right, as m is least upper bound of sequence Sn. So m is less equal L, it implies that limit of sequence Sn as n tends to infinity is limit of sequence Tn. The next example, find limit of this sequence n raised to minus n minus 1 into n plus 1 raised to n. So the solution, n plus 1 raised to n, so I can write it as, if I take common this term n raised to n, so it will be 1 plus 1 by n raised to n for positive integer n, and then if I divide it by n raised to n plus 1, so what I will get? Divide by n raised to n plus 1, so what I will get? N raised to n will cancel, so it will be 1 plus 1 by n raised to n divided by n. Therefore limit of this n raised to minus n minus 1 into n plus 1 raised to n is same as limit of 1 upon n into 1 plus 1 by n raised to n, and as we know the limit will be, it is 0, and this limit will be e, so it is 0, so is the limit. The next example, if sequence Sn is 10 raised to n upon n factorial, then the question is find a large n, that means positive integer n, such that the n plus first term is less than Sn for all positive integers greater than this large n. So let the nth term is 10 raised to n upon n factorial for all n positive integers n. Then we consider Sn plus 1 should be less than Sn, and it implies that what is the n plus first term? 10 raised to n plus 1 upon n plus 1 factorial, it should be less than 10 raised to n upon n factorial. It means what? So cancelling the same terms on both sides, so what will get? The 10 upon n plus 1 term will left on left side, and on the right everything will get cancels. So it means that is n plus 1 should be greater than 10, and it implies that n should be greater than 9. So what we should have to get this? N plus first term should be less than Sn. So for what value of n it will happen, n greater than 10, right? So if we choose a positive integer n such that the large n to be, if we choose it to be greater than 9 or greater equal 10, then the n plus first term of the sequence is less than nth term for all n greater equal n, and which it's have chosen it to be greater than 9. The next example, I think it is example 5. It is for a positive integer n. Let Sn is 1 into 3 into 5, the product up to 2n minus 1 divided by 2 into 4 into 6 into product up to the term 2n, 2 times n. Then sequence Sn is convergent and limit of sequence Sn is less equal half. So we have to show this. So Sn is given. So as Sn is 1 into 3 into 5, the product up to 2n minus 1 divided by 2 into 4 into 6 up to the term 2n for positive integer n. So let us consider Sn plus 1. So what it will be? 1 into 3 into 5 into the term 2n minus 1 for n equal to n, and for n equal to n plus 1 it will be 2n plus 1. N plus 1, n is replaced by n plus 1, so it will be divided by 2 into 4 into 6 into 2 times n into, for n equal to n plus 1, it is 2n plus 2. And now observe that I can have as 2n plus 1 upon 2n plus 2. This thing is definitely less than 1, right? So this product or this thing will definitely less equal 1 into 3 into 5 to 2n minus 1 divided by 2 into 4 into 6 up to 2n. That means this thing is nothing but Sn. So what we get? Sn plus 1 is less equal Sn for positive integer n. So it means what? Sequence Sn is non-increasing sequence, and all the terms of Sn, all the terms of sequence Sn are non-negative. It means therefore Sn is greater equal 0 for all the positive integers n, and it means that sequence Sn is bounded below. So what we can say? Sequence Sn is non-increasing bounded below. Hence sequence Sn is convergent, and as it is convergent, what the limit of sequence will be? As n tends to infinity, the limit will be greatest lower bound of the terms of the sequence. So what the greatest lower bound? For n equal to 1, what the S1 will be? 1 half. For n equal to 2, S2 will be 3 by 8. For n equal to 3, S3 will be 15 by 48, and so on. So 3 by 8 is definitely less than 1 by 2. 3 by 8 is definitely greater than 15 by 8, 15 by 48. So it is, and the greatest lower bound will definitely less equal 1/2. So it is what we wish to show. Limit of Sn is less equal half. Okay, let me give some assignment. So the assignment number 4. Question 1 is, if limit of sequence Sn upon n is equal to L and which is non-zero, then sequence Sn is not bounded. Prove this. Assignment 2nd, if sequence Sn is bounded sequence of real numbers and sequence Tn converges to 0, then sequence Sn into Tn converges to 0. Then the next assignment, a non-decreasing sequence which is not bounded above diverges to infinity. The next one is a non-increasing sequence which is bounded below is convergent. So it is analogous to the theorem that a non-decreasing sequence which is bounded above is convergent. So it is analogous to that theorem. Then next thing is number 5. For a positive integer n, let sequence Sn to be 2 into 4 into 6 up to the term 2n, divide by 1 into 3 into 5 up to the term 2n minus 1 into 1 upon n square. So verify that S1 is greater than S2 is greater than S3 and so on, and prove sequence Sn is non-increasing. Okay. Then the next thing is, for a positive integer n, sequence Tn is 1 plus 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus 1 upon n factorial. Then prove that number 1, sequence Tn is non-decreasing, and number 2, sequence Tn is bounded. Okay, is that sufficient? Okay.